Have you ever thought about the air around you? It's everywhere, pressing in on us, stretching for hundreds of kilometers above our heads. A huge, invisible ocean of air. We call it the atmosphere, and honestly, it's the only reason life on Earth is even possible. So let's take a journey through this incredible life support system.
But first, let's start with a wild thought experiment. What if it wasn't here? I mean, what if in a single instant, our entire atmosphere just, poof, vanished? What do you think would actually happen to our planet?
Well, it would be an absolute catastrophe. Without this protective blanket, there'd be nothing to filter the sun's brutal, raw heat. By day, we would literally be baked alive. And then at night, with no air to trap that warmth, the temperature would plummet, and we'd instantly freeze in the cold of deep space. It's this atmosphere that keeps our world in that perfect, livable, sweet spot. So, what is this life-saving blanket actually made of? You can think of it like a recipe. Let's break down the ingredients for the very air we're all breathing right now. Now, you might think the air we depend on is mostly oxygen, right? But that's not even close. Get this, a whopping 78% of the air is nitrogen. The oxygen we actually need to live, that only makes up about 21%. And that tiny little 1% sliver, well, that's a mix of all the other gases. And every single one of these ingredients has a crucial job. Nitrogen is absolutely vital for plants to survive. Oxygen, of course, is what we and all the other animals breathe. And then there's carbon dioxide, which plants take in to create their food, and in return, they release the very oxygen we need. You see? It's this perfect, delicate partnership.
Okay, so our atmosphere isn't just one big, uniform blob of air. No, it's actually structured into 5 totally distinct layers, and each one has its own unique personality. So let's take a trip, an ascent, from the ground we're standing on all the way to the very edge of space.
So here's our roadmap for the journey. We're going to start at the bottom, in the troposphere, and then climb our way up through the stratosphere, mesosphere, thermosphere, and finally reach the exosphere. All right, first stop, the troposphere. This is our home. It's the layer we live in, the air we breathe. It goes up to about 13 kilometers, and most importantly, it's where pretty much all of our weather happens. Anytime you see a cloud, feel rain, or hear a thunderstorm, you are witnessing the troposphere in action. Moving on up, we hit the stratosphere. This layer stretches all the way up to 50 kilometers, and it's famous for one very, very important reason: the ozone layer. Think of it as our planet's built-in sunscreen, shielding us from the sun's dangerous ultraviolet rays. It's also completely free of clouds and weather, which is exactly why airplanes love to cruise up here for a super smooth ride. Climbing even higher, we enter the mesosphere, which reaches up to 80 kilometers. This layer is basically our planet's cosmic shield. When meteorites come screaming towards Earth from space, this is the layer where most of them burn up, creating those beautiful shooting stars we sometimes get to see at night. Next stop, the thermosphere. And this is where things start to get a little weird. In this layer, the temperature actually shoots up really fast the higher you go. It's also home to something called the ionosphere, a layer of charged particles that has a really cool trick up its sleeve. It bounces radio waves. This is what makes long-distance radio communication possible all around the world. And at last, we've reached the top, the exosphere. This is the final, uppermost layer. The air here is incredibly, incredibly thin. It's barely there at all. This is the final frontier, where our atmosphere just sort of fades away, and light gases like helium and hydrogen can actually escape Earth's gravity and float off into space. Okay, our ascent is complete. Now let's head all the way back down to that very first layer, the troposphere, and take a closer look at the powerful engine that creates all of our daily weather. But first, let's clear something up really quick. People often mix up weather and climate. Weather is the short-term stuff, what's happening right now or what it's going to be like today. Climate, on the other hand, is the big picture. It's the average weather you can expect in a certain place over many, many years. Now, a huge piece of the weather puzzle is air pressure. It might feel like nothing, but that column of air above you has a weight, and it's constantly pressing down on everything. That pressure is strongest down here at sea level, and it gets weaker and weaker the higher up you go. We don't feel it because, well, our bodies are built for it. They push back with an equal amount of pressure from the inside. But check this out. This is a wild fact. On the moon, there's no air, which means there's no air pressure. So an astronaut without a protective suit would be in serious trouble. the pressure from inside their own body would cause their blood vessels to burst. Isn't that crazy to think about? So how does all this pressure stuff create wind? It's actually beautifully simple. When air gets hot, it expands, gets lighter, and it rises. That leaves behind an area of low pressure. Cold air does the opposite. It's dense, it's heavy, so it sinks, creating an area of high pressure. Nature always wants to find balance, so air will always rush from a high-pressure area to a low-pressure area. And guess what? That movement is what we feel as wind. Another key part of weather is humidity. All that means is the amount of water vapor hanging around in the air. You ever notice how on a really muggy day, your wet clothes take forever to dry? That's because the air is already jam-packed with moisture, so it can't really absorb any more from your clothes. And since warmer air can hold more water, that's why humid days often feel so hot and sticky. So we've seen how the atmosphere is this amazing, dynamic system of gases and layers and pressures that creates our weather. But it's also a very delicate balance. A balance that directly shapes our entire global climate. And at the very heart of this balance is something called the greenhouse effect. And you know what? It's a good thing. It's a totally natural process. Certain gases, like carbon dioxide, basically act like a cozy blanket for our planet, trapping some of the heat that radiates off the Earth. Without this natural effect, our world would be way too cold to live on. Here's the problem, though. We are starting to upset that natural balance. By burning fossil fuels like coal and oil, we're pumping billions of tons of extra carbon dioxide into the atmosphere. We are, in effect, making that natural greenhouse blanket thicker and thicker and thicker. And this is what happens next. When that blanket gets too thick, it traps too much heat. All that extra trapped heat causes the Earth's overall temperature to rise. And that's the phenomenon we all know as global warming, which has huge effects on our planet's climate. So, as you can see, from the air we breathe, to the layers that shield us, to the complex systems that create our weather and regulate our climate, it's so clear that the atmosphere isn't just empty space above us. It's a complex, interconnected, and absolutely essential life support system. You know, every single breath we take is a gift from this incredible system. It protects us constantly and makes our entire world possible. So, the final question we have to ask ourselves is this: how do we make sure that we protect its future? Thanks for joining me.